Good morning, guys. Sorry, I do not know what the deal is with. I don't know why it kicked me out of my own stream. It's not very nice. But good morning. It's been forever. Hopefully, I don't lose a ton of people because of that. We get to start probability today, which is a very fun thing to learn. And I don't know. Probability is an interesting subject to me. It's also one of the things that I had the hardest time with in school, and it's not because it's hard. I just don't know if I don't know why. I think my brain is just not set up for this kind of thing. But which is funny because I love math. Anyway, so don't feel bad if probability feels like foreign to you or something, because I understand it's the same for me. It's a different genre of math, I feel like. So it can feel kind of weird. But that being said, it's very fun to learn. And what you're learning today is not stuff that's hard, or this whole year, it's not going to be hard. Just different. So, while I'm waiting for more people to jump on here, I also am going to say for anybody watching this later that I keep getting the question how to make up participation points if you miss the stream. So I know everyone can't be here for the stream. So if you want participation points ever on any lesson, you just comment your name in the comments. It sends me an email so I know when you do it. And I can just give you participation points for that day. So that's all you have to do. Super easy. And I'm not taking points away for being like later than normal. It's just full participation points for anybody who puts their name in the comments, or if you're here in the live stream, you just put it in the chat. So, okay, I'm gonna get started. Hopefully everyone else can catch up. Okay, we're gonna be talking specifically about sample space and just sort of general probability today. So first of all, let's do a definition here. A sample space is the group of all possible, that's what goes here. Let me zoom in. Of all possible outcomes in the probability scenario. So when you hear the word sample space, you should think, okay, what is the group of everything that's possible? All the possibilities that could happen in this probability scenario. This will make more sense once we do these three problems down here. We're going to do examples of sample space. Something to note is that I don't know. Most of you know that I like made these books, right? Clearly, because there's weird directions here. So I don't know what I meant to say, but it just cuts off after no need. So anyway, question mark. The real direction here is to express the sample space in each scenario. So in number one, it's just rolling a six-sided die. So every possible outcome is you either roll a one or a two or a three or a four or a five, right? Or a six. Almost missed one there. That's the group of all possible outcomes in that probability scenario. There are six of them. Super easy, right? Of course. Number two, it gets a little bit different because we have a more complex probability scenario. So here we're spinning two spinners to create a two-digit number. So the first spinner is going to be the tens digit, and the second spinner is going to be the ones digit. So whatever you spin on the first spinner is going to be the first part of your number, and the second spinner is the second part of your number. So here's my recommendation. Hang on one sec. Okay. My recommendation for when you're trying to find sample spaces is to organize yourself, because if you just start listing things randomly and try to figure out what you don't have, it makes it very hard. So the organization that I'm going to be using when I'm listing these possible outcomes is that I'm going to start with just one number. So say I just spun a 2 on the first spinner, because that's like the first thing that comes here. Hang on, let's highlight. So I'm just gonna list all of the possibilities that start with 2. So if I roll a 2 on, or I spin a 2 on the first spinner, then my second spinner could give me a 4, which would give me a 24, or it could give me a 6, which would give me a 26, or 27, or 26 again, or 25. Do you see how I just did that? I went around this spinner for the second digit of the number. So there's my first number. This first spinner can also spin a 1. It spins several 1s. But that means we have a 14, a 16, a 17, a 16 again, and a 15. So once you get the hang of this, you'll start to see the pattern and it'll get really easy. So hang on, let me get a different highlighter. And now we're going to do 3 as the tens digit. 34, 36, 37, 36 again, and 35. In some probability scenarios, they don't have you list duplicate numbers. So, for example, we have 2 of like the 6s, so 26, 2 16s, 2 36s. In some scenarios, you don't have to list those. I'm going to list them just so that we can see where they're coming from instead of just like stopping randomly. Like I want you to be able to see what I'm doing here. Because notice we have another 1 on the first spinner, so that means I'm going to have the same list as I did in the orange. And then the last one is also a 1, so the last list is also going to be the same. So we have a lot of duplicates. That's supposed to be a 15. Yeah. And that's okay. In this scenario, we're just going to list all of them just so you can see where they're coming from. So again, organize it. It helps a lot. Okay. The third one is pulling a shape from the bag and then pulling another one at random. So something I want you to note here is that if you pull a shape out of the bag, that shape is no longer in the bag for you to pull out another shape, right? So you've removed one shape from the probability. So that's just something to think about as we're making our list of possibilities. Problems with probability have to state whether or not you're replacing the thing that you pulled out, or else it's not going to be like you can't answer the question, right? It's going to say if you are putting it back or if you're keeping it. In this scenario, we are not putting it back. We're just keeping the shape, yeah? So I'm going to make some vertical lists here. I'm trying to make them even. Okay, so I'm just going to start with the triangle, one of the triangles. So I'm going to say I pull out a triangle, and that's going to be the first thing I pull out in every one of these situations. I don't know how many I'm going to have yet. So if I pull out a triangle, there's a possibility I could pull out a second triangle because there's 2 triangles, yeah? So that's a possibility. If I pull out a triangle, there's also a possibility I could pull out a square. And there's 2 of those, so that is another outcome that I could pull out that other square, or you could pull out a circle. Yeah. There's also another triangle, so I'm gonna actually have to repeat that list, and I'm gonna explain why. Um, we're treating them as separate right now, even though they're exactly the same. Like I said, I want you to see what's happening here, see my organization rather than just the outcomes, right? So a lot of times you are not so, or you don't have to list duplicated outcomes. Um, However, I like to know that there's duplicates because sorry, somebody emailed me. I like to know that there's duplicates because that counts as another outcome. Even if they're both the same, it's two separate outcomes, and you'll see why that's important later. You have to know how big the sample space, how many total possible outcomes there are. So my second column here is going to be the same as my first because I have two triangles that I can pull out first, right? There's two triangles. So if I pull out the other triangle first, then I could also pull out the first triangle second. Wow, that was more confusing than I meant it to be. You know what I mean. And then my triangle and square option, and then another triangle and square option, and then another triangle and circle option. Okay, now we're going to say the first shape we pull out is a square. After we pull out a square, we could pull out a triangle. We could also pull out the other triangle. We could also pull out the other square, or we could pull out a circle. And again, we have two of those squares, so we can make a whole other list with those same outcomes because now I'm starting with the other square. Triangle, square, triangle, square, 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 circle. I'm actually going to make myself room down here to keep going because there's also a circle option. So if I pull out a circle first, I could pull out a triangle second, or another triangle second, or a square, or the other square. And that gives us our final 4 outcomes. So in total, we have 4, 8, what's the next number? 12, 16, and 20, right? Yeah, 5 times 4. So there's 20 possible outcomes. So understanding how many possible outcomes there are is super important for finding probabilities. So a probability describes a decimal or a fraction. Fractions are most common. Fractions are sort of what you start with in a probability because the top of a fraction, a probability fraction, this is how many, we call them favorable outcomes, which is funny because actually it doesn't have to be good. Those are just the outcomes you're looking for. So if your problem is saying what's the probability of pulling out a triangle and another triangle, then that's your favorable outcome. It doesn't necessarily mean that it's good. Like you could be looking for the probability somebody gets eaten by a shark, and we would still have to call those like favorable outcomes. Just a weird math thing. That's basically what we're looking for. What probability are we looking for? What the outcomes are that we're seeking, and then the bottom is always the total number of possible outcomes. You have probably done this before in your life, hopefully. If not, it's fine. We'll learn how to do it. So you start with a fraction in probability. If it's asking for a decimal or a percent, you still start with a fraction. And to get to a decimal, you just divide it in a calculator. And I'm going to write that just so we can remember it. Divide in a calculator. Can't fit it. And that will give you a decimal. And then if you're looking for a percent, you change that decimal into a percent by moving the decimal twice to the right. Is that the right direction? Yeah. Move the decimal twice right. You know how to do that. Moving from decimals to percents. Move the decimal. So now we're gonna try some problems here. And the first one, we're gonna use a keyboard here. And forgive the things that, okay, so like, okay, I'll explain that in a second. So basically we're just like spinning around a keyboard, and then a friend randomly presses a key with their eyes closed, right? So we're gonna assume here that the probability of hitting each key is the same, which obviously it's not. If you think about it, it's much more likely that you hit that space bar than like the D, right? Because it's like way bigger. So the probability is more. We're going to assume that that's not true, that all the keys are the same size and it's equally likely that we hit any of those keys. Just for the sake of probability, we kind of have to fudge that a little bit. I just wanted this problem to be interesting, but like also, I don't know. Anyway, so we are going to we're going to assume that each key is equally likely to be hit. So I'm going to save you the trouble of counting the keys because I did, unless you want to double check me, which would be great. But the total number of keys is 59 on this specific keyboard, not on all keyboards. I don't know. I haven't checked. So the size of the sample space, the total possible number of keys that could be pressed is 59, which means that the bottom of most of our fractions, for our probability fractions, is going to be 59 because that's how many total outcomes are possible. So I want you to do this for your name. The first problem says, what is the probability of the key being pressed? Wait, sorry. Let me read that again. What is the probability of the key pressed that the key pressed is a letter in your first name? That's why it's not grammatically correct. Sorry. Basically, you're looking for your name. How probable is it that they hit a letter in your name? So I'm just going to use Tommy. Yeah, so I'm going to use Tommy. The possibilities here, the number of favorable outcomes in this name, I want you to do yours. T-M-O-N-Y. Notice that there's not 5 possibilities because the M is repeated, so there's actually only 4 letters, right? In total, because there's, yeah. So that is 4 keys out of 59. So there's 4 favorable outcomes out of 59 possible outcomes. So you do that with your name. While you do that, I'm going to be highlighting some keys here, and you will see why in the next problem. It's going to be messy. Okay. The next problem says, what is the probability the key pressed is not a letter? So that is why I just highlighted all of that in orange, because I highlighted most of the things that are not letters. I'm still not done yet. These are also not letters. There's a blank key, don't know why, on this keyboard. And 4 down there. So my book says that there are 26 keys that are not letters. Double check me on that, maybe, if you feel like it. But that means that there are 26 favorable outcomes out of 59. 26 of those keys are not letters, and that's the probability that we were looking for, so that becomes our favorable outcomes, is pressing a key that is not a letter. Number 3. What is the probability the letter pressed is a number? So there are only 10 numbers, because there's 1 through 9 and 0. So there are 10 keys that are numbers, and 59 as our total again. And hopefully this is making sense. Please ask questions if you are confused. I'm going to be holding a study session today. Your homework for this unit, I tried really hard to make it short because the principal is getting on us about giving you too much work. So I'm trying to follow his direction. So anyway, your homework is going to be shorter this unit, although the questions tend to be more involved. So I don't know. Anyway, it still should take you less time. So anyway, I'll be holding a study session if you feel confused after this. What is the probability that the key pressed is an even number or a vowel? So now we have added in a couple of other possibilities, right? So how many even numbers are there? There's 2, 4, 6, 8, and 0. We're counting 0 as an even number. So that gives you, wait, how many did I just say? 2, 4, 6, 8, 0, 5. Half the numbers, that makes sense. So even numbers, there are 5. Vowels, there's A, E, I, O, U, right? We're gonna count Y? Let's not count Y. Yeah. And there are 5 vowels. So that means in total, that possibility is the same as the one above. There are 10 keys that would either be an even number or a vowel out of 59 total keys. Okay. Let's talk about notation really quick. This is important for math-based reasons. This is often how they write what they want you to find. It's weird because it looks like function notation, and it kind of resembles its meaning, but there is no function that you're plugging it into. There's no like function called p of x or something. And they always use p and n or maybe m for possibilities. Anyhow, so what this means, all that it means is that we're finding the probability of the event n. So n is the favorable outcome that we're looking for, and the p of that just means the probability of that event happening. So the way that we say that is we say the probability of whatever that event is. So this is some kind of event. Essentially, what outcome we're considering. So you'll see an example of that below. But so that's the notation they use a lot in probability. They'll just say what is p of like even or something. So like say it's like a rolling a dice situation, like a rolling a 6-sided dice. They might say p of even, like that, that would just mean what's the probability of rolling an even number on a six-sided die? What's the probability of rolling an even number? So that's what that notation feels like. Yeah. Okay, so most of you know that I'm a giant nerd, and especially for D&D, and so I could not teach you D&D without revealing my ultra nerdiness because D&D is all about probability. So anyhow, endure with me as I nerd out on you for a second. I promise this is actually useful. Um, so so in D&D you use a six-sided or 20-sided die a lot, which is I don't know of any other reasons to use a 20-sided die. I don't know what any other games or like board games or anything that uses a 20-sided die. Anyhow, so it kind of makes it unique that you have more possibilities on that die. So it has an explanation here, and I'll just read it for the sake of clarity. And I promise that the game rules are not important. um, and it will make more sense when we're just finding the answers to these problems. So anyway, in D&D, characters use a 20-sided die to determine if an attack hits like a monster or a bad guy or something, right? So to hit, the number they roll must be equal to or higher than the armor class of the monster. So the monsters will have some sort of number that means how hard they are to hit. And so the characters have to roll a number that's equal to or higher than that number to hit with their attack, right? And we're going to read the rest in a second after we do a couple of problems. So let's just let that sink in. So on a 20-sided die, this is number one. On a 20-sided die, it says, what is the P of greater than 5? So what that means is that what's the probability of rolling a number, oh, sorry, less than. That is a less than symbol. Hello. That is saying the probability of less than 5. So the probability of rolling a number less than 5, there are only 4 numbers less than 5 on a dice, right? 1, 2, 3, 4. 5 is not less than 5, so we can only count those 4 numbers. And there are 20 total possibilities on a 20-sided die. So the probability is going to be 4 favorable outcomes because there are only 4 outcomes that are less than 5 out of 20 possible outcomes. You can actually reduce that to be a 1 in 5 chance. That is, MathSpace is going to make you do that. If there's a fraction that you can reduce it, because MathSpace doesn't want to let you leave it, I don't think. You can also get decimals and percents if it asks for it. Just remember you have that guide on the other side of this page for how to do that. Okay, number 2 says, if the monster has an armor class of 13, what is the probability of hitting the monster? P of hit. It's the probability of hitting it. So again, the rules say that if you have to roll a number that's equal to or higher than the armor class. So how many numbers are there equal to 13 or higher than 13? So we have to count 13 because if you roll a 13, you also hit. So 13, 14, 15, 16, 17, 18, 19, 20. There are 8 possibilities. Favorable, right? Out of 20, what did I just say? 8 out of 20 possibilities, which reduces to 2 out of 5. Okay. Okay, so this is where I find this game gets interesting, right? So we're gonna keep reading the explanation up here. I'll highlight it so you know what I'm talking about. Oh, yikes. So modifiers are bonuses the character can add to their rolls. So essentially, if you can have like a +4 or something that makes the probability of hitting something higher. So so if the next problem says if the monster has an armor class of 20 and the character has a modifier of +2, what's the probability of hitting it? So, meaning that when the character is rolling the dice, then they can add a 2 to whatever they roll. So, the only way that they're going to hit this monster is if they get a 20 or above, which means that they could roll an 18 because they would add 2 and get 20. They could roll a 19, add 2, get 21, or they could roll a 20 and add 2 and get 22. Hopefully this is making sense. Again, super nerdy, but very fun, just in case you're wondering. So the favorable outcomes here are 18, 19, and 20, which are 3 of the dice roll possibilities out of 20. So the possibility of hitting is 3 out of 20, which does not reduce, in case you're wondering. Okay, last one, promise. If you have a modifier of -1, what is the probability that you will miss a monster with an armor class of 12? So we're saying miss means less than 12 because we're not trying to hit the monster, we're trying to miss it. That's favorable. So we're looking for numbers that are less than 12, which there are 11 numbers less than 12. However, you have a -1 as a modifier, so you would subtract 1 from whatever you roll on the dice. So you could roll a 12 because if you -1, then it'll become 11 and that will be a miss. So, and you can also roll a 1 and -1 and get a 0, which would be super bad. So, so the number of favorable outcomes here are 1 through 11 are fine. So is 12 because you're subtracting 1. All of those would make you miss. So all the numbers from 1 to 12 will be a miss, which means that 12 numbers, 12 possibilities out of 20, those are our favorable outcomes, which reduces to 6 out of 10, which reduces to 3 out of 5. 3/5. Okay, I'm gonna stop berating you with nerd stuff now. You know, it's the best. Okay, that's all I have for you for this lesson. Again, I will hold a study session later if you're confused or having issues. Yeah, I think that's all. Happy Friday on this like dreary day. I don't know if it's dreary where you are, but it's like doing that sad almost rain. It's been doing that all morning. Anyway, happy Friday. I hope you guys are doing well. I miss you. Like, it's so sad. I'm sad, but it's fine. We're good. Yeah. What else? That's all, I think. Okay. Well, I will post the link for the Google Meets call if you want to hop on anytime in the next. I think I will do from like 11 to noon, probably, maybe a little after that. But you'll see on the Google Hangouts. So, okay. Hopefully that made sense. Good luck on your homework. Have a good weekend and keep your chin up. Also, thank you guys. Oh, I didn't say this. That was the other thing I wanted to say. Thank you guys for your Tangent Day apocalypses. Apocalypses? I don't know if that's plural. Anyway, they were thoroughly entertaining and I appreciated them. I was like laughing for like an hour yesterday reading all of them. So I feel like making a highlight reel or something, but I don't know if I'm committed enough to do that. Anyway, I will see you on Tuesday because that's the next time I'm going to stream. Yep, or in a Google Meets call in case you need that too. Okay, bye guys.